Alrighty, let's put these in the context of the livers. So we looked at a cluster, a solution, and then how the livers lever come in. Liver, lever, whatever. Lever. In India we say lever. I think in the US they say lever. SLCP lever, short-lived climate pollutants, take immediate action to cut emissions of short-lived climate pollutants. And what are the short-lived climate pollutants and their response to mitigation effort? We have black carbon, methane, tropospheric ozone, and hydrofluorocarbons. So you have to be careful. These have short lifetimes or residence times, whereas HFCs, some of them have very long lifetime residence time, but it depends on how they are used. Okay, so in the aerosols, in the labs, in coolants, cooling systems, and so on. Okay. So black carbon, there are the anthropogenic sources, transportation, indoor cooking, power production, and so on. Lifetime in the atmosphere is days. Impacts and the mitigation. Impacts will be largely local and regional. The impact at global scale is relatively small. Methane comes from cattle and wetlands and leaks from oil transportation and burning of the excess pressure, the excess gas at oil drills and land dumping systems. Has residence time of about 12 years, highly reactive, so typically gets converted to carbon monoxide and then carbon dioxide. It has mostly global impacts. Tropospheric ozone comes from the photochemical reactions in the atmosphere from emissions, and they only last weeks, and they only have local and regional impacts with barely any effect at global scales, but all the regional impacts obviously add up to the global impact, right? So we do have to be mindful. Plus, these are also very dangerous for human health. So that's also something we must remember. HFCs already, these sources I mentioned, 15 years of lifetime weighted by usage, and this is a long-lasting gas that has global impacts. And remember, the global warming potential of these are methane is about 25 times when you consider concentration and time period. Ozone is also very large. HFCs, I think, are several hundred times the global warming impact of carbon. So we have to be aware of those as well. So looking at this again in a different way, here we are on the historic warming, and here is the future. Business as usual would get us up here, CO2 only and CO2 plus methane. CO2 plus black carbon, methane, and HFCs would bring us below 2 degrees by 2100, which is very critical in the way we understand the impact of 2-degree warming by now. Okay, so black carbon and methane are contributing about 0.5 degrees by 2050. Hydrofluorocarbons about 0.1, short-lived climate pollutants 0.6. So this is the additional warming compared to just fossil fuel emissions of CO2. Hydrofluorocarbons, high global warming potential, but the concentration is still low. So we have to worry about the concentration, their global warming potential, and their residence time, right? That's critical. The carbon lever, on the other hand, asks us to drastically reduce emissions of carbon dioxide to near zero levels before the end of this century. So the bad news there is that there's good news. Many of the countries have committed to Paris Agreement, and they have provided the targets for voluntary emission reductions. Voluntary, it's a democratic process, so it's good, but verification period is going to come up soon. And even the commitments made are generally considered off target. So the world's current climate change promises under Paris Agreement amount to a case of running just to a standstill. To hold warming to 2 degrees Celsius or less, emissions in 2030 would have to be sharply lower. So here are the numbers. 2030 Paris goal is at 53, and we're already at 53.5 in terms of CO2 emissions per gigatons per year. By 2030, to stay below 2 degrees C, we have to get down to 40. If we want to hit 1.8, we have to get down to 34. If we have to hit 1.5, we have to get down to 24. Okay, so obviously we need to combine the CO2 and SLCP. So that's the advantage of SLCP, that they have immediate impact and they have lots of co-benefits as well. Okay, so atmospheric carbon extraction is now being tried at various levels. This is from Canada. This is from Reykjavik, which is in Iceland. So they are capturing carbon at source at a geothermal energy plant. Okay, so awareness is high, green market incentives are high, and general goodwill to reduce emissions is high. But reality keeps hitting. For example, the tsunami that was caused by an earthquake in Japan in 2011 caused damage to the Fukushima Daiichi nuclear plant, which led Japan to renege on their commitment to burning coal, for example. There is Volkswagen's example of a corporation going greedy and cheating on emissions and getting caught. So this is always going to be maybe a 2-step forward, 1 step back kind of dance. Decarbonization is not easy even for individuals. If you are very keen on reducing your carbon footprint, you have to constantly watch from morning to evening, not just how much water and energy you use, where your food comes from, how much you're wasting, how much cooling and heating you are doing, how much you are driving, etc. Right? So the system itself needs to change to allow people to contribute effectively. And that includes these SLCP lever and carbon lever. Are we really in a position to rejig the entire infrastructure to make fast adaptation of new technologies, low carbon and zero carbon technologies? That's a big challenge we face.